we're going to start with sodium 23, Na23. Now, how many protons are in sodium always? 11. So we have 11 protons. And how many neutrons does that mean we have in sodium 23? 12. And we're going to assume for now how many electrons? 11. The same as the number of protons. This is sodium. Now hopefully you guys can see pretty quickly why, to me, it's important that you memorize some of this stuff. Because otherwise you have to look all this up, right? But because if you guys haven't memorized, you don't have to look up Na, you know it. You don't have to look up how many protons, which is 11, so that you can subtract to get 12. Does that make sense? Because you memorize it all, this all goes much faster, right? So I have sodium 23, 11 protons, 12 neutrons, and 11 electrons. Now over here I'm going to write kind of the model of what to follow. All right, so I'm going to draw the nucleus as much as I care to. Okay, I'm done. All right, so the first circle, the first orbital, if you will, is called 1s. 1s. So somewhere off to the side on your paper, or at the top of the page or whatever, I want you to write what I'm going to write up here. So for our orbitals, we have S's, P's, D's, and F's. S orbitals hold up to 2 electrons. P orbitals hold up to 6 electrons. D orbitals hold up to 10 electrons. F orbitals hold up to 14 electrons. The order of energy we're going to say is 1s, 2s, 2p, 3s, 3p, 4s, 4d, 4p, 5s, 5d, 5p, and this continues on. Now, we're going to learn how to modify this slightly tomorrow or the next day, but we're going to start with this. And you will not have to memorize that order because you'll be able to look at the periodic table and know it. Haley, you probably learned to go diagonal, yes? So you probably learned that, yes? Okay. So what we're going to do is break it down into further detail than that. So we're going to do this is one, this is one, this is one, this is one. Make sense? All right, the only exception will be this will eventually be 3D. Instead of 4D, this makes this 4D. Everything else will be the same. All right? So this is how you learn it in chemistry class. Don't worry about this for now. All right? So this is our energy levels. So the first one is 1s, right? 1s is the first one. How many electrons can an s hold? 2. So I'm going to put 2 s's on here. 1, 2. You can make circles, you can make dots, you can put minus signs, you can put e's. I will pretty much always put e's on mine. Now there are some chemists who freak out and really want you to separate these e's. They might say something like, well, they have to be separated. Why would they say that? Electrons have what charge? Negative. And two things with like charges repel, right? Like charges repel. And so in theory, these things separate from each other. Why would I not care to separate them on the diagram? Doesn't really matter because it's a diagram, but we don't want to diagram incorrectly. They're moving. All of it's moving. And so to try to draw something stationary in a certain place when it's moving, right, doesn't make sense to me. Right? If we were to make a diorama of an African savanna and we put the giraffe here, we don't want this idea that the giraffe is always standing in this one place, right? The giraffe moves, right? So to make people think it's always in one place, is to emphasize we got to put the giraffe right here, doesn't really make sense because sometimes the giraffe goes over here. All right? And so to me, to freak out about this doesn't make sense. Some teachers do. And if you have a teacher down the road that does, then just move the electrons. To me, it's just I can write them faster by putting them all in one place. Doesn't matter. All right? So 1s. All right, what's after 1s? 2s. How many can an s hold?
2.
Up to 2. How many electrons do we have total now?
4.
4.
Oh.
And we're going to how many? We're trying to get to 11. We're 4. What comes after 2s?
2p.
2p. 2p. And how many can a p hold? Up to 6. 1, 2, 3, 4, 5, and 6. How many electrons do I have total now? 10. How many more do I need? 1. Need 1 more. 11 minus 10 is 1, not 2. Got it. All right, so 1s, 2s, 2p, 3s. Now, how many can a 3s hold?
2.
But how many more do we need?
1.
Just 1. It's pretty simple, right? We're just filling in the maximum each time. Yep.
Is like the highest we're going to go, 5p there?
It goes past that.
Oh, it does?
Yeah. And you'll be able to look at your table and know them. All right. So we're going to call this, we'll say, the highest energy level, we're going to say is 3s, and then we're going to write a superscript 1. And what that means is we have 1 electron on the 3s level. You guys see that? 3s, how many electrons? 1. 3s, 1 electron. It's like an exponent, superscript. 3s, 1. Everybody good? Let's look at another example over here on this side of the board. We're going to look at phosphorus 31. Phosphorus 31, P31. P31. How many protons in phosphorus?
15.
15. How many neutrons in phosphorus 31?
16.
16. And how many electrons are we assuming at this point? 15. All right. Very good. So we're just going to start in the middle here. 1s can hold how many? 2. After 1s we have 2s. It's an s, so it can hold up to 2. 2p can hold up to 6. 3, 4, 5, 6. That gives me a total of 10. I need how many more? 5 more. 1s, 2s, 2p. What's after 2p? 3s, that can hold up to 2. So now I'm at 12. And then 3, after 3s is 3p. And 3p can hold up to, but how many do I only need?
4.
3. So subtraction's killing us. Electrons, guys. 15 electrons, what we're going for. So I would write that energy level as what? 3p3, very good. 3p3. How did you get that? 3p is the outer orbital, and there's 3 electrons on it. 3p3. All right, so we have one more example. We have one more thing to add after this too, and then we're going to do some modifications to your periodic tables as well. All right, so let's look at, we're going to look at the example. I just fell over. We're going to look at the example of zinc 65. Zinc 65. ZN65. How many protons in zinc 65? 30. How many neutrons in zinc 65?
35.
35, very good. And how many electrons are we assuming for now? 30, very good. You guys have done really well with this so far today. All three classes. What's my first circle? 1s. 2 electrons. And then 2s, and I'm writing small intentionally here. This is going to get kind of big. Imagine if we were doing like uranium or something. Right? 1s, 2s, 2p. P's hold 1, 2, 3, 4, 5, 6. It gives me 10 electrons. After 2p, I'm at 3s. 1, 2. Alright, so I'm at 3s, it's total 12. Then I'm at 3p. P's hold. I'm at 18. After 3p, I'm at 4s. 2 electrons. I'm at 20. I need 10 more. After 4s, I'm at 4d. And d's can hold up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Wait, so now 4P. Okay, we skip it. 4P.
Comes after 4d.
Oh, wow.
And that order will make more sense soon. Caden, did you start learning these at academic team last week?
Yes.
Probably called this 3D.
Maybe.
Okay. I'll come back to Y tomorrow. I forgot you guys were doing that. That's what I was trying to explain it to Haley before. All right. And so we would call this set of electrons what energy level? 4D10. Now get out your periodic table. We're going to make some adjustments to it. All right, on the left side, your periods are not labeled. So we're going to label your periods just 1 to 7. So, my book's upside down. 1, 2, 3, 4, 5, 6, 7. Pretty simple. Just go down the left side. Each period, each row is 1 to 7. 1, 2, 3, 4, 5, 6, 7. Across the top, you're going to label the first two groups S1 and S2, but use superscript numbers like we just did. Like this. All right, so this would be S1 and S2. S1, S2. Then on the right side, these 6 that are a little taller than the rest will be P1, P2, P3, P4, P5, and P6. P1 to P6. On the middle section, the transition metals, we're going to go D1 to D10. D1 to D10. And then the bottom section will be F1 to F14. F1, F2, F3, all the way to F14. Anybody notice anything intriguing about the numbers? They match what? Right. we made 2 S columns, right? Made 6 P columns, 10 P columns, 14 F columns. All right, now ready? Ready for a cool trick?
No.
Okay, so let's look at sodium. Where's sodium? It's right here. Sodium is in what period? What period? 3. And what column? S1. 3 S1. Look at zinc. Zinc is right here. It is in 4D10. 4D10. All right, last one. Let's see if we're really that smart. Phosphorus, 3P3. All right? Yeah, see that? So we can always check our work to make sure we've done it correctly by checking what the book says, by looking at our periodic table and knowing where they are. All right? We have one last thing to add to this. So if I ask you, what's the highest energy level of polonium? PO. Polonium. PO. What's the highest energy electron there? 6P4. Very good. 6P4. You don't have to draw all of that, do you? It's not like you have to sift through 84 electrons to figure it out. Sometimes you'll have teachers, and I'll actually accept these as test answers, but it's easier to make sure your work's right if you do all the electrons. But I'll say draw the outer orbital of polonium. That's really simple, right? It's 6p with 4 electrons on it. That's it. Right? Okay. All right, now we're going to look at electron configurations. We're going to add one more thing to this, and then I'm going to turn you loose on those 3 problems. So we're looking at electron configuration. That's basically the rotation of the electrons. All right? So I'm going to work on sodium right here. Actually, I'm going to erase the side. I'm going to draw a line there, and I'm going to erase the side of this orbital so you can see it. This is going to go with sodium, though. I just want to keep it next to the orbitals. All right, so basically, we're going to draw arrows to represent the electrons. If an up arrow represents this, a down arrow represents this, opposite spin. So it's going to spin this way or this way. Arrows represent electrons. It's really all I've said so far. All right, so the rotation. So picture the planets spins, right? It rotates. So before, look. Both. So look, ready? Don't freak out, just pay attention. So the planets revolve around the sun, right? Same is true here. But these planets also rotate at the same time, right? Yeah. The electrons are rotating. Some of them are going to rotate clockwise. Some are going to rotate counterclockwise. All right? So picture like this. Make sure you listen with your face. So if we picture... Probably easier if you see me. All right, so if an up arrow does this, a down arrow does this. Does that make sense? Whatever, it's arbitrary, but whatever direction up represents, down represents the opposite direction. Does that make sense? They're going to spin opposite ways. Okay. All right, so they're going to be drawn in pairs. All right? So if I can have two, right? S's can have 2. If they come in pairs, how many lines do I need? Just 1, right? Because if they're going to come in pairs, right? So 1s has how many electrons? 1s has can hold 2 electrons. So I'm going to draw an up arrow and a down arrow. It's going to have 1 going each direction. Arrows are electrons. There's 2 electrons there. What's after 1s? 2s. 2s can hold how many electrons? 2. So 1 line coming in pairs. Up arrow, down arrow. 2 arrows, 2 electrons. What's after 2s? 2p. Now, 2p can hold how many electrons? 6. Now, if they're coming in pairs, how many lines do I need for those? 3. Now here's where one trick comes in. It's not really going to matter on this example, but I want to show it to you anyway. We're always, so each line can hold an up and a down arrow, but we want to fill all of our up arrows in first. All right? So I'm going to do up, 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 down, down, down. So each line will have an up and a down on it, ultimately. So there's 6 electrons on that. What's after 2p? 3s, and s can hold 2, so it needs how many lines? Just one line. How many electrons do we need in that? Just one. Just gonna draw an up arrow. Now, for those of you guys that just freaked out, because I saw about 5 of you start crying a little bit, let's look over a couple things. First of all, I think everybody got the circles, right? Everybody good on circles? Everybody's good on the orbitals. 1s had 2 electrons. 1s has 2 electrons. 2s had 2 electrons. 2s has 2 electrons. 2p had 6 electrons. 2p had 6 electrons. 3s had 1 electron. 3s has 1 electron. All we're doing is making our electrons be arrows instead of putting them on circles. They come in pairs. Yes?
So for each complete orbital, like sort of like one, each time one arrow's going to be up and one's going to be down?
Yes. If we fill them all in, yes. All right, so this would be 3s1, 3s1, 3s1. We have 3 different modes of modeling this. They're all the same. And that's what we want.
Wait, so we have to use all 3 of them?
You will, yes. All right, let's come back to example back here, phosphorus behind me. All right, so on this one, 1s holds how many electrons? This can hold up to 2, so I draw one line. We have both electrons. After 1s is 2s, can hold up to 2 electrons, it gets one line. And then 2p, up, 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 down, down, down. Now I'm at 10 electrons, trying to get to 15. 1s, 2s, 2p, 3s is next. And now I'm at 12. I need 3 more electrons. And after 3s is what? What's after 3s? 3p. And that can hold up to 6. Now, how many electrons do I need to put there? 3, right? Because I'm trying to get to 15. I'm already at 12. Where do those electrons go, Brittany? What?
Like up arrow on the first line and down arrow and then
Nope. What did I say over there? All up. So I do up, up, up. I get no down arrows. Which means what, Madeline?
They're all spinning.
Yes, exactly. All spinning the same direction.
Because they don't have a partner.
Yeah, nobody wants to dance by themselves, so just dance the same way it's have to. Seen some weird people. So 3p3, 3p3, 3p3. All 3 ways that we've looked at this have 3p3. If this were a test, which won't be for a while, but if this were a test and you put up, down, up, that would be wrong. Or if you put all downs, or if you put up, up, and up on the first 2 lines, it'd be wrong. It's got to be like that. All right, we fill in the up arrow on each line first. All right, one more. Let's look at zinc over there. Zinc and all its wonderful electrons. All right, 1s, up, down, 2s. I'm going to kind of fill it in and let you guys fill in behind me. Questions? All right, here's what I want you to do. Actually, one more thing. Looking at your table, why don't I make you memorize the order? Why don't I make you memorize this? Because the table gives it to you, right? 1S, 1, 1S2, 2S1, 2S2, 1S, 2S, 2P, 3S, 3P, 4S, 4D, 4P, 5S, 5D, 5P. They go in order. All right, starting at element 1. 1S1, 1S2, 2S1, 2S2, 2P1, 2P2, 2P3, 2P4, 2P5, 2P6. 3S1, 3S2, 3P1, 3P2, 3P3, 3P4, 3P5, 3P6. 4S1, 4S2, 41, 42, 43, 44. Right? They go in order. We just start at element 1 and go. They go in order. No reason to memorize them. All right? S's, S's, P's, S's, P's, S's, D's, P's, S's, D's, P's. Right? All right. Here's what I want you to do. On the board, you have 3 problems I want you to do. I want you to write protons, neutrons, electrons like we've been doing. The name, draw the orbitals, the electron configuration, the energy level. Neon 20, potassium 39, and sulfur 33.